Chinese MIG welding inverters are cheaper. Apart from lower manufacturing cost, is there any design criteria, compromise in design and oversimplicity? Let us check inside details of a MIG inverter with external wire feeder unit. Inverter power source takes 3 phases, 400 volt, 50 or 60 Hz mains power. A power supply input cable is connected to the rear end of the machine. MCB is given to switch input power for on or off purposes. Option is given for CO2 gas heater supply. Supply can be taken out from this socket. The circuit breaker reset is mounted to reset heater over current trip. A fan is provided inside to take air for forced air cooling. On the front side, power and trip LED are mounted for indication. This switch is for setting 2-strokes or 4-stroke selection and also for crater on or off. Another switch is given for gas check or weld mode selection. Welder to set parameters from the panel. This display shows welding current and this display shows welding voltage. These 2 potentiometers are for crater current and voltage setting. Another potentiometer is given for inductance setting. On the lower side, 2 OKC terminals are for welding positive and negative power supply connections. The socket is given for connecting interconnection control cable to wire feeder. Wire feeder is so-called dumb wire feeder because no intelligent component like PCB is mounted in it. Positive power cable is to be connected from power source to wire feeder. Now coming to the inside components of the power source. We have removed the top cover of the machine. Input 3-phase power wires are coming to MCB. Output of the MCB 3-phase wires are going to input filter board. Here input filter is basically EMC filter. This filter is without power factor or harmonics correction circuits. Below the filter board, there is a distribution PCB. Supply is going to fan from here. Over and under voltage protection purpose proportional voltages are going to the control PCB. 2 control transformers primary inputs are also coming from here. From first transformer 110 volt AC is going to heater socket via circuit breaker. From both transformers, secondary voltages are going to control and wire feeder PCB. Wire feeder PCB communicate with wire feeder and also takes crater voltage and current values from front panel potentiometers. 2 front panel switches send gas check and 2-strokes 4-stroke signals to wire feeder PCB. Power and fault LED are also connected. Finally processed signals are sent to control PCB. Control PCB takes inductance set value from the front potentiometer. Welding current and voltage values are displayed on the front panel 7-segment displays. Control PCB sends gate signals to power PCB for IGBT gate driver. Another 3-phase outputs from filter PCB are going to input rectifier. Outputs of the rectifier are positive and negative DC bus voltage, going to IGBT bridge. Here is the circuit diagram of the components that we have described. Input power, MCB, filter PCB, distribution PCB, rectifier block, control transformers 2 number, fan, heater socket and circuit breaker, control PCB, wire feeder PCB, front components. Next to see lower part of the machine. 4 IGBTs are connected in full bridge configuration mounted on the heatsink. From IGBT's connections are going to primary of the amorphous core main transformer. Secondary of the main transformer is in center tap configuration. Center tap of the transformer is going to iron core choke. From choke, connection is going to a shunt for welding current monitoring. From shunt, it is going to negative output terminal of the machine. Proportional current feedback from shunt and voltage feedback across output terminals are going to control PCB. Other lower side components details are as follows. 2 ends of the main transformer secondary are going to output rectifiers mounted on a heatsink. Output of the rectifiers is going to positive output terminal of the machine. Filter is connected across output terminals. Power source circuit diagram is now ready. DC bus voltage is coming across IGBT bridge. This is IGBT bridge, 4 IGBTs. From IGBT bridge connections are going to primary of the main transformer. Main transformer secondary connections are output rectifier to positive output terminal. Center tap is going to iron core choke, then to shunt. After shunt, connection is going to negative output welding terminal. Most of the DC bus power components are 1400 volt rating. High value of DC bus filter capacitors are also absent in this type of design. Next to see wire feeder circuits. From power source positive output, positive welding power cable is connected to this power terminal. Interconnection control cable is coming to wire feeder control terminal from power source wire feed PCB. Interconnection controls are analog signals. No complex digital communications protocol are implemented. However, number of control wires between the power source and wire feeder are reduced by some tricky design. Welding spool can be mounted on this hub. MIG welding wire can be fed by motor through this feeding mechanism to the output euro and finally through welding torch. Here feeding mechanism is single roller drive. Wire feeder motor is also without any encoder or take-o feedback. Motor is a servo motor and driving voltage proportional to speed are coming from the wire feeder PCB. Gas solenoid is connected here to control gas flow. Gas pipe coming from cylinder to solenoid input. Other control connections from control inputs are going to remote box and very much tricky. Torch and wire inch, both signals from the switches are used by a single wire. Two signals are differentiated by voltage drops. Voltage drops across resistive circuits are different for each switch. Torch signal will come from the torch by operator through euro connection. Single wire is also used for voltage and current signals from two potentiometers. Pulsating waveform from the wire is segregated by diodes for positive and negative cycle. Finally, the full circuit description. Welders set welding parameters from the power source panel and wire feeder remote box. When welder presses torch switch, pressing signal pass on from wire feeder circuit to power source. Wire feeder PCB, as per the setting, controls motor speed for welding current, gas, and operation logic. It passes voltage setting signal to control PCB. Control PCB drives IGBT gate PWM high frequency. Main transformer and output rectifier convert low voltage AC into DC welding voltage. Control PCB measure welding voltage and current by shunt. Control PCB modify PWM signal as per the feedback. DC choke gives required damping and energy. Control PCB also monitors temperature and input supply and trip the machine in case of outside limit values. Thanks for watching.